Let's prove that all dragons share a tail. Okay, how should we start? Let's say we know one thing, that for all x, let's consider the universe of dragons. For all x, there exists a y that's a tail, and x, the dragon, has y, the tail, as a part. So that's our premise. Let's see if we can prove that if that's so, then in fact all dragons share a tail. We can use universal instantiation to say, well, if this is true of all dragons, then it has to be true of any dragon, and in particular, how about making it true of some representative dragon we'll call D? So there you go. Now let's deal with the existential quantifier. We'll use existential instantiation and say, well, if there exists a tail, then let's just call it T. We don't know anything else about that tail. We'll call it T. So T is a tail, and D has T as a part. Now, T and D are arbitrary values. We've made no additional assumptions about them. So we can use universal instantiation to say, well, then these claims have to be true for any such values. And so for all x, remember x is the dragon, has this T as a part. And now we ought to be able to use existential generalization to say, well, if this is true of T, then there is some tail it's true of, and we'll go ahead and do that. And now we have, there exists some tail such that all dragons have it. Now, should we have been able to do this? Does this follow from our claim? And the answer is no. It's not true that all dragons share a tail. So what went wrong? Let's start over and see if we can figure out where we went wrong. We start with the premise and the first step that says that the claim has to be true for all dragons. So far, so good. The problem now is what we did as step 3. We claimed that there is a particular tail, and every dragon, including this representative dragon, has the same tail. That's not okay. That's not what existential instantiation lets us do. And the reason is that the original existential quantifier occurred inside the scope of this universal. It says that you give me an x, then there exists a tail for that x. But it doesn't say that there exists one tail for all possible x's. Are we stuck? Can we write anything? No, there's something we can do. What we have to do is to use existential instantiation right and replace the y with a function of the particular dragon. You give me a dragon, what I know is I can find a tail for him. And we call these functions Skolem functions. And if we use Skolem functions right, then existential instantiation is sound. It won't let us derive drivel in the way we did a minute or so ago. Now that we've got this, we can continue. And yes, we can generalize to an arbitrary dragon. So we have for all x, there's some tail that's a function of x, and x has it as a part. That's fine. And now, can we do that last step? Can we assert that there's one tail that goes with every dragon? That's what we were able to do last time. Can we do it? And the answer is no, we're stuck. Because what we don't have here is that there is a particular tail. We have that there is a function that produces tails, but not that there exists even one particular tail. Why might that be? Is it the case that there are any dragon tails at all? No. When might there be no dragon tails? There might be no dragon tails because there are no dragons. Do you see any dragons? Do you see any dragon tails? We've been blocked from concluding that there exists even one dragon tail, and that's right. We can't defend that based on what we know. So this line that we were able to do before isn't allowed by the sound version of existential generalization. There you have it. Do all dragons share a single tail? Nope.